In this demo, we will go through a few steps. We will first talk about the architecture that we are trying to use in this lab. It is assumed that you would have used the cloud and CloudFormation template available here in this location to set up the lab environment and go through the first two demos, which is using the application discovery service to uncover application data, as well as using Cloud Endure to do migration of those servers from the simulated on-prem environment to the target AWS environment, which is US West 2 in this case. This demo on DMS depends on those two demos being complete. Now, when it comes to the reference architecture, we started with assuming two different applications running inside a private subnet on an on-prem data center. And those two applications are WordPress and Offbiz ERP. And these application servers and database servers, four in all, have been migrated to the target environment on AWS using Cloud Endure. And we saw that the migration was successful. We shut down the source environments. We updated the DNS to point to the new environments in AWS, target VPC and target subnet, and then validated using the fully qualified domain names that those applications remain accessible, and we considered the migration of those servers successful. Now, one thing to note is the migration that we did using Cloud Endure, where we are replicating each server like to like on the target environment, is what we call a lift and shift migration. It's also called a rehost strategy for migrating to the cloud. So here you do not change anything within the server itself. You just change the host from an on-prem, probably a physical or virtual server, to a cloud-based virtual server. That's what we did. Now, another strategy to migrate to the cloud involves replatform. And a good example of that is converting a self-managed database like MariaDB or MySQL or Oracle to a managed service like RDS, which supports multiple flavors of databases, including open source as well as commercially available software. And that is done using a service called Database Migration Service, which allows you to migrate a source database to a target database when either of them are on AWS platform. Now here in this reference architecture, as we said, there are two different applications. The WordPress application itself uses MariaDB database on the backend, and the Offbiz application uses three PostgreSQL databases. So for the purposes of this demo, we will target to move both of them to Aurora. The first one, MariaDB, will be migrated to Aurora MySQL, and the three PostgreSQL databases will be migrated to Aurora PostgreSQL managed database instances. It will be three databases on a single RDS instance. Now, with that in mind, let's start the hands-on demo. So, at a very high level, these are the steps we will go through. We will first create those two Aurora databases, RDS instances, and then set up the databases on those instances. Create users to access WordPress as well as Offbase applications. And then we will go and configure DMS on the DMS console. We'll go through a few steps of configuring the DMS. And then we will execute the replication tasks, which will migrate those databases, and then execute a cutover, update DNS, and validate. Let's get started. So when we head over to our AWS console, this is the CloudFormation template we use to bring up the lab environment. And we have gone through a few steps on the migration hub. We have discovered using application discovery service 4 servers which were running 2 applications. We had to manually group those servers into these applications. And then we explored EC2 instance recommendations. And we also created a Cloud Endure project, and then created blueprints and set up the blueprints and replication settings for the Cloud Endure project, and kickstarted a migration that did replication of those on-prem servers onto the replication server, and then we executed a cutover on Cloud Endure, which created these servers on the target AWS environment. Then we shut down the old servers, updated the DNS, and made sure that the new servers are working fine. So with that, these application lift and shift migrations are complete. Now we look at what are the tools that are available for migration, other types of migration. So DMS being one more service. So just to quickly check, we have a few instances running, and out of which these servers whose names end in onprem sim.env are the target servers that are created by Cloud Endure after the cutover has been executed. And each of these are running in the target VPC and the target private subnet. And those are what we did in the previous demo. All right. So now we move to the first step of the demo, which is creation of the target RDS instances. So let us go to the RDS console and start creating the two RDS instances. The first one being the Aurora MySQL for WordPress database. So we go to the RDS console and click on create database. We choose the details. We'll do standard create. We'll do Amazon Aurora with MySQL compatibility for the first one, which is WordPress. And then we will keep the latest version. We'll do dev test for the purposes of this demo. We will give it a name that is easily recognizable. And then for credentials, we will keep the same password that we have been using. All right. And then we'll choose a smaller burstable class. We will go with a lighter weight instance to avoid high costs. For VPC, we will select target. Publicly accessible, no. VPC security group, we will choose an existing one and we'll select default and add the one that contains target security group. And we'll pick the first one. Then we'll move on. Password authentication. This is WordPress DB. Uncheck enable encryption, enhanced monitoring, and then click on create database. Let's give it some time. All right. The database is now creating. We will go ahead and create the second RDS instance as well. This time Aurora for PostgreSQL for the off-biz application. We'll go through similar steps. This time we'll select PostgreSQL compatibility. And rest is very similar. Dev test. Password AWS ID 20. Instance class burstable. DBT3 medium. Don't create replica. Choose target. Select target security group in addition to default. Select the first availability zone. Password authentication is enabled by default for PostgreSQL, so you don't have to do anything more here. For database options, you can leave this one blank because we'll be creating them through command line manually. We will need to create more than one database for the RDS instance supporting the off-biz application. No need for encryption, no need for performance insights, and no enhanced monitoring required. So with that, we will create this one as well. Oops. All right, I got this one wrong. This needs to go in here. This is admin. Sorry, this is off-biz. Click on create database. Give some time. And there you go. This is creating. So the WordPress instance is already created. So you can see connection details here. This is the username and password that you gave. And this is the endpoint. You can copy this endpoint and keep it handy. Let's copy this over to all right. We'll get rid of this extra text. All right. Now we have created both databases. We will need both database instances. So within these databases, we will need to create the databases. One more piece of information that you would need to note down is for each of the writer instances of the database clusters that we have created, you go into the details and okay, while this is still creating, let's look at the WordPress instance that has already created and it is available. So let's go to the endpoint of the writer instance and note that one down. Similarly for the off-biz instance, which is now available, you have an endpoint that you can copy from here. All right. So these ones are the writer instances. All right. Now let's go back to the WordPress writer instance. Remember, we have a Bastion host running in the private VPC that we can use to connect to rest of our instances. You use putty to SSH into each of the database instances. Let's start with the WordPress DB. Remember, the WordPress DB has already been migrated. So the server we are connecting to with this domain name is the one running on the target AWS environment. So here the command to use to connect to MySQL on the Aurora instance from here would be this one. All right, we are connected to the Aurora MySQL. We will use all right. That's it. We created the WordPress user on Aurora MySQL database. Now we'll move on to do something similar for the PostgreSQL database that we created on Aurora RDS instance. Remember, this was created as a cluster with no database name, so we'll have to manually create that. So let's open putty again and go to AWS DB server, AWS MID 20. So we will establish a session from this Bastion host. This is the DNS value for the writer instance. We'll plug into this. Go to our Bastion, connect it to AWS DB server, execute this, AWS MID 20 again. That's the one we are using it consistently to avoid confusion. So we will do that. So here we will execute a series of SQL commands to create database, 3 databases to be sure. So this one, do this. We're creating 3 databases, and we are done with that. All right. Just to recap, for the WordPress DB, when creating the RDS instance, we chose to create an initial database called WordPress DB. Here, we created a user by name WordPress with this password and granted them all the required privileges. In the case of PostgreSQL RDS instance, we did not create any initial database. Here, we are creating 3 different databases that are required by the Offbase application. So with this done, we are ready to jump into our management console and start setting up the DMS service. So let us go to DMS, which is the Database Migration Service. As we said, the high-level steps to configure DMS service are creating a replication network, launching the replication instances, and then creating the endpoints for source and target. The first thing we will do is to create subnet group for WordPress MySQL replication. So we'll go to subnet groups and we will create a subnet group, give it a name. Description is optional, so I'll keep it the same. We'll create it in the target VPC. We'll click on create subnet group. You need to select target Aurora and target private and click subnet group. Similarly, create another one, this time for Offbase. VPC would be target again, and then target Aurora, target private, and create subnet group. All right. Now the next one would be to create a replication instance. So go to replication instances and create a replication instance and provide these details. This one is just a unique name. ARN is optional. Description is just plain text. You can select a small instance. This is fine. EPC should be target. Publicly accessible, not required. Network configuration, you select the WordPress subnet group that you just created and select the availability zone that we used when creating the RDS instance. And then under VPC security groups, select default as well as target security group. Default, target, rest is fine. So similarly, we'll create a replication instance for PostgreSQL. We'll give it a unique name, description, instance class is fine. EPC should be target and not publicly accessible. Advanced security, Offbase is good. Availability zone should be the same one. Security groups, target security group. As well as default. And then click on create. All right. Now, now is the time to create a bunch of source and target endpoints. So as we know from the earlier walkthrough of the architecture, we are dealing with four different databases, one MariaDB and three PostgreSQL databases. The first one is MariaDB to MySQL, and the rest of the three are PostgreSQL to PostgreSQL. So for all these migrations that we have planned, we need to create an endpoint for each of the source and each of the target. So those are 8 different endpoints in all. I know it's tedious, but it's worth creating by hand for a small demo like this. For large scale migrations, you would be doing scripting to do creation of these endpoints in mass. Let's start. So we are at the third step of configuring DMS. All right. You go to endpoints and click on create endpoint. So a couple of things we'll need here. One is the private IP for each of the EC2s that is hosting the source databases. So let's go to the EC2 console and go to WordPress DB and capture the private IPs. Similarly for Office DB, all right, let's save that. Going back to the DMS console, we are at create endpoint screen where we can start creating the source endpoint. For for WordPress, we will supply the following details: endpoint identifier, not this one. Source engine is going to be MariaDB. ARN is optional. Provide information manually. Server name would be the IP address that you have just copied for MariaDB, which is WordPress DB currently. Port will be 3306 for MariaDB. Right. Rest is optional. So one good thing to do is to test the endpoint. Test a connection. So this is WordPress. See, the test is successful, so all good. We'll create more endpoints. This time we'll create a target endpoint. This one is RDS. Select RDS DB instance, and we're creating it for WordPress instance 1. Provide information manually, server name, password, AWS MID 20. It's a good idea to run this test. Choose target, select WP and run a test. Alright, the target connection was also successful. We'll similarly go ahead and create the remaining 6 source and target endpoints. Similarly, we are creating a source endpoint for the second OFBIS database, which is OFBIS OLAP. So we supply similar details and we are running a test. Successful. So we create an endpoint. I want to create a target endpoint for the same. Target endpoint will be RDS OFBIS. OLAP. All right, the test is successful. So we have one more pair of source and target endpoints to create. So this one is for OFBIS tenant. So let's do that. Source engine is going to be PostgreSQL. manually get the source IP address for the server name, port 5432. Username is going to be offbase and database name is going to be offbase tenant. Password is your standard AWS MIT 20. Let's test the connection. All right. So now we create the last endpoint, which is a target endpoint for offbase tenant. Give it a useful name. Manually password. Database name is offbase tenant. Run a test. All right, this one looks good. So we now have 8 endpoints created, 4 source and 4 target. That should be good for us to proceed to next step. All right. With configuration of DMS complete, we are now ready to move on to the last step, which is the migration and cutover. The migration executed by creating a set of DMS replication tasks for each pair of source and target endpoints. Let's jump into the DMS console and we will create a total of 4 migration tasks, one for each pair of source and target. So there would be one MySQL replication task and 3 PostgreSQL replication tasks for each database that needs to be migrated. So for MySQL, let's go to left side navigation has database migration tasks. Click on create task. And we'll have to provide some details for each task. Task identifier, descriptive name is optional, replication instance for WordPress is WP, source database for WP, target database for WP, and you migrate existing data. You can use default values for most of these things. For table mappings, you go to wizard, add new selection rule, enter a schema, click on create task. You can have automatic creation of task upon create. So it will launch the replication task as soon as this task gets created. So that will save us some time. So let's continue to create tasks, and in the backend, any task that we create. All right, I think we will need to use a new window to create a new task. That's fine. So let's move on to the next PostgreSQL task. This is offbase. Replication instance would be offbase, source offbase, target offbase, migrate existing data. Rest of it can stay the same. Add a new selection rule, enter a schema, wildcards. You can automatically click on create, start migration task. All right, as you can see, one has already created and it is starting. Let's continue to create other tasks. This one is for offbase tenant, offbase OLAP. application instance is going to be offbiz all app source, offbiz all app target, migrate existing data, add new selection rule, enter a schema, leave it as default, automatically create. The first one is already running. Now you create last migration task. This one is for offbiz tenant. Replication instance is going to be offbiz. Source is offbiz tenant. Target endpoint offbiz tenant. Table mappings. Add new selection rule. Enter a schema. Leave wildcards. Automatically start the migration task upon create and click on create task. So now you have created all four and all of them are in different states. And if you give it enough time, all of them will be running and reach the load complete stage, at which point all your source databases using the source and target endpoint migration endpoint configurations have been replicated to the target instance by the DMS service and they are ready for your cutover. Okay, after waiting for a few minutes, we see that all four databases have fully replicated. Now it's time to shut down those source servers, do a DNS update, which is the actual production cutover, and then validate whether the applications are still running fine once the DNS update has been completed using the target instances that we have just replicated. So in order to update the DNS and shut down the source database, we will log into Bastion and go to the WordPress database initially, and we will look at the NS lookup records, and we will load the Aurora WordPress endpoint that we have noted down earlier into a local variable and then use it to update the NSLOOKUP database records, DNS records, and then we will shut down the server. And after which we can validate that the WordPress site is still working, and we will repeat the same steps for the offbeat server as well. Let's go on to the Bastion host. Let's first bring the endpoint of offbase server, sorry, the writer instance of Aurora. Copy it here. We'll copy this all into a Bastion host notepad. All right. Let's go to WordPress DB. Let's look up. So it's pointing to 10.0.1.121, which is an EC2 instance. So let's execute this. Then when you do and let's look up for this domain name again after this update, you should see the RDS instance endpoint. With this, you're now ready to shut down your old server. So now the WordPress DB server is down. So if your cutover was fine, your WordPress instance should still work. So you can see that the cutover seems to have been successful without any downtime. So you're still able to access your application while the database has been migrated from your EC2 server to an RDS instance. We'll do similar steps for the off-base server as well. So the only difference is this is off-base DB. And then for this address, you will bring the writer instance of off-base. Rest is all the same. So let's copy this to your Bastion host notepad. Let's try this lookup first. It points to your EC2 instance. Let's load this up. All right. Let's do this again. Okay, we did a small mistake. This host name needs to be offbase DB. I think we overwrote the WordPress DB. So let me fix that. All right, let us fix this. Luckily, we saved this. Then do this time with the correct host name. All right. Now, if we do ns lookup on offbase DB, it should point to offbase DB's RDS instance. Similarly, if you ns lookup WordPress DB, it should give you WordPress instance. So now you are ready to shut down the offbase DB instance as well. Okay, now let's test both applications. Now let's first test WordPress. This still seems to be working fine. Let's see if it has some of our test comments that we put in. Looks good. Let's see if we can run the offbase application too. Admin offbase. All right, seems to be working fine. Let's see if it has some of the entries that we made. New store was something we created. All right, looks good. So that brings us to the last step, which is validation, which we just did. So let me correct this. All right. So we went through a long process and we detailed it out as we went. So we started with the databases running on EC2 instances that have been migrated using lift and shift strategy using Cloud Endure. And once we had applications validated and running in that mode, we then used a database migration service to set up replication endpoints, replication instances, and source and target endpoints for each of your database that you wanted to migrate from an EC2 instance where you are self-hosting and managing the database to a managed service like RDS. And once you have set up all those replication instances and the source and target endpoints correctly, all you need to do is create replication tasks and execute them. And once the replication tasks show the status as load completed, you are ready to do a cutover by shutting down the old server and redirecting your DNS entries for the database endpoint to point to the RDS endpoint. So hope that was a useful demo of DMS service. Catch you at some other time. Thank you.